Hello everybody, my name is Thien. I am a PhD student at the National School of Architecture of Toulouse, France. I will present my research with title The Impact of Urban Morphology on Housing Indoor Thermal Conditions in Hội An City, Vietnam. First of all is the object of the research. The objective of this study is to assess the impact of urban morphology on the indoor thermal conditions of housing in Hội An City. The research process is carried out by a variety of methods, including in situ survey, measuring with temperature sensor, data analysis, and map analysis. For houses located in two areas with different urban forms, were selected and implemented the measurement within 1 month to investigate the difference in housing indoor temperature. From there, the impact of urban morphology on housing will be evaluated specifically. The keywords in this research are urban morphology, indoor thermal condition, ancient town, vernacular house, and modern terrace house. The main contents of the study are listed in table of content. The first part is introduction. General information about Hội An will be mentioned. Part 2 is the urban morphology of Hội An City. In this part, research areas are assigned and site selection criteria are also specified. The important content in the second part is the analysis of urban morphology in two designated study areas. The name of part 3 is Field Measurement Work. Step to install, operate, as well as information about location and time to install measuring equipment in each house will be discussed in detail in this part. Part 4 presents the data collected, giving discussion and comments on that data. Part 5 is conclusion, and finally is the references. Part 1 Introduction. This is a picture of Hội An ancient town with bird's eye view. Hội An is a coastal city in Quảng Nam province in central Vietnam. In the 16th and 17th century, Hội An was a famous trading port in Southeast Asia. Hội An survived after devastating war in the late 18th century. Hội An was one of the few places in Vietnam that retains most of the main urban structure. Hội An City has an ancient town which was recognized by UNESCO as a World Cultural Heritage Site in 1999. The research objectives are analyzing and assessing advantages and disadvantages of urban morphology of two areas. The first is Old Town area, I mean Hội An ancient town, and New Urban area is the second one. Perform measurement of indoor air temperature. Consider the relationship between indoor temperature condition and the urban morphology. Part 2 The urban morphology of Hội An City. The conservation project of the ancient town of Hội An was approved by the government in 1997. In the figure 1, the boundaries of Hội An City were established. The city can be divided into two areas, the old urban area and the new urban areas. See figure 2, the new urban areas are formed by urban expansion due to urban pressure, and they are divided into two parts. Part 1 is an urban area with direct access to the old towns, called an old town buffer area. Part 2 is the whole new city on the outside. In addition, there are areas of agriculture located nearby, both in the control and joint activities of the whole. Now we will move to the new sections, positions of research areas. Figure 3 shows the diagram of research area. There are two areas selected for surveying in this research, the Old Town area and the Old Town buffer area. In each area, a typical road is selected to survey. Trần Phú Street at the Old Town area and Nguyễn Hiệu Street at the Old Town buffer area. In Trần Phú Street, two vernacular houses A and B chosen to take the measurements. Meanwhile, in Huong Street, two modern terrace houses, C and D, chosen to take measurement. I choose the research locations based on some of the following criteria. The first one is geographical location within the cities. The distance between two survey areas to the river water surface are similar, therefore they will be able to receive the same impact as river winds water from the rivers. Moreover, location of two areas are adjacent to each other, so the difference in weather like temperature, humidity, winds is not so far. The second criteria is contrast between ancient and modern. Chongfu Street is the oldest street in Hoi An ancient town, so it will bring the most characteristics of the old town. Meanwhile, Huong Street has the modern directions. The final criteria is characteristics of building. The two selected streets have the east-west directions, so the selected houses will have the same directions. House A and House B are the typical vernacular houses in Hoi An ancient town in layout, facade form, and the roof materials. Meanwhile, House C and House D are the modern houses with the common layout and form. We come to the important part in Part 2, Hoi An Urban Morphologies. In this research, analyzing urban morphologies is based on the analysis of the general plan, front facade, and cross-section of two selected streets. The first section is analysis of the general plan. According to the figure from Hoi An government and other research papers, the construction density and population density in the Old Town area is higher than the Old Town buffer area. In Figure 3, the enlargement of the Old Town area, the location of the alleys is marked. Small alley width only 1 meter to nearly 2 meters. They start from Bạch Street, crossing the Old Town and into the residential area behind Chongfu Street. These alleys are not only for moving purpose, they also provide the cool breezes from the river to the building deep inside the Old Town. In Figure 4, the radius of 50 meters around the four survey houses were enlarged to show the amount and location of trees around them. The distributions of canopy trees and climbing plants in the two survey areas is shown on the map. The Old Town area has fewer canopy trees than the buffer area. There are very few canopy trees on both sides of Chongfu Street, mainly climbing plants. On Huong Street, there are many canopy trees along both sides of the road. The trees here have a wider coverage than the trees on Chongfu Street. The second section is analysis of the street facades. Figure 5 and Figure 6 show that all vernacular houses in this picture have a front porch. There are not too many cabinet trees around the survey houses. There are only some climbing plants and ornamental plants. However, thanks to the large front porch, reduce the direct sunlight into houses. The common form of roof in the Old Town is sloping roof, which is covered with yin-yang tile. Facades of vernacular houses are usually pure concrete or wood, and the walls on both sides of these houses are brick walls. Most of vernacular houses in this old town are trading local goods for visitors or making restaurants, coffee shops. However, the activities of trading and display products inadvertently seal on space in front of the house, restricting the access and circulation of air. Figure 7 and Figure 8 show that most of the houses in the photo do not have a front porch. The awnings are added after construction. The main materials of the awnings is canvas and corrugated iron. Particularly for houses, there is no porch and awnings. The front part of house is used as a shop. There are many cabinet trees around houses and houses. These trees can create shade for the main facade of the building, replacing the porch. The roof front of two-story houses or more ground houses and housing is sloping tile roof. However, for the one-story houses in this picture, the mainly use corrugated iron roof. This can cause an increase in heat in the area because of the heat reflections of the corrugated iron roof. The final section in Part 2 is analysis of the street cross-sections. Figure 9 and Figure 10 show the street cross-section at the four houses where installed the temperature measuring sensor. We can see that the width of Nguyễn Street is larger than Trần Phú Street. In the old town, most of the movement of people on Trần Phú Street is walking, and the number of tourists visiting Hội An ancient town is very crowded, so the release of heat in the old town area is quite difficult. Meanwhile, the width of Nguyễn Street is large. The sightseeing activity are not strong on the street, and people use vehicles to travel, so the congestion of people and vehicles are rare on this street. We come to Part 3, field measurement work. The evaluation of the impact of urban morphology on indoor thermal conditions in this research is mainly based on indoor air temperature. And to measure the indoor air temperatures, I use the equipment, temperature sensors, and Arduino microcontroller board. Measurements were made by installing temperature sensors at similar locations in four survey houses. These sensors will be connected and transmitting data to an Arduino circuit. This Arduino is connected to Wi-Fi and continuously records the measurement parameter every 2 hours. The reader can access the data by website or app on mobile phone. In case of power outage or loss of Wi-Fi connections, the data will be stored in Arduino memory and uploaded later. Next section is position of measurement station. Figure 13 shows the position temperature measuring device in the plan and in the sections of four survey houses. The temperature measuring device will be located 3 to 7 meters away from the main door and at the height of 1.2 meters above the ground. The main reasons for choosing such a placement: first one is it necessary to find device location so that they are equivalent between the two kinds of houses. In vernacular house A and P, measuring device put within the main building, and in the modern house C and D, measuring device put in the living room. The distance of 3 to 7 meters for the main door to avoid the direct sunlight on the device, called deviation, when measuring the temperature. Moreover, an important reason is that the device needs to be mounted near the power supply. And the second one is temperature measuring device is located about 1.2 to 1.5 meters from the ground, because if placed too close, it will measure the temperature of the ground. While placed is too high, it will be skewed by the temperature 10 by 8. The measurement periods chosen for this research work were June 2019. June is recorded as one of the months with the highest average temperature in Vietnam. Therefore, June time is appropriate month to monitor indoor air temperature conditions when the outside air temperature rises significantly. In addition, 27 June had the highest average temperature in June, according to data from Da Nang Meteorological Department. Will be selected to investigate temperature variation every 2 hours at survey houses. We will come to Part 4, result and discussion. The measurement of average air temperature at the four stations in 1 month are shown in Figure 14 and Table 1 for the same climate conditions. Observing Figure 14, the average air temperature data at house A is the highest compared to the remaining houses, and it is higher than the data obtained from the meteorological station. Following house A is house C with approximately the same temperature. House B is the third highest average house temperatures, and house D is the house with the lowest average temperature background and the lowest temperature fluctuation range among the four houses. Vernacular housing in Hội An has adapted fairly well to climate conditions. However, this temperature survey showed the opposite result. The average air temperature in two vernacular houses A and P are higher than the modern house C and D. It can be explained that, in addition to the impact of architectural forms, the indoor temperature conditions are also affected by urban morphologies. There are some disadvantages of the old town area such as narrow streets that restrict air circulation, lack of greenery that increase the ground temperatures, display goods that take up horizontal ventilation space for housing. Meanwhile, modern housing and D are located on an open road with many trees, reducing the impact of sunlight on the roof and the road surface. Limiting heat build-up increase the air temperature. However, housing with a small area compared to the other survey houses, temperature measuring device is located near the cooking area, so it will affect by temperature data obtained. According to the Figure 15, the measured air temperature in the four stations are higher than those recorded at the meteorological station from after the afternoon to tomorrow morning. Discrepancy in temperature after 5 p.m. to 7 a.m. tomorrow morning at four houses, and the meteorological station fluctuated between 1.3 degrees Celsius and 5.1 degrees Celsius. This can be explained by the presence of traffic and the surface absorbability characteristics. During the night, building material dissipated heat to the surrounding air and lead to the increase of indoor temperature. The final part, conclusion. The morphology of the urban surrounding fabric forming the street influences the variation of indoor temperature. Open streets will promote air movement that lower temperature of horizontal surface such as roof and road surface. Roof covering material in the Old Town area and the Old Town buffer zones are called asphalts. Therefore, shading should be enhanced such as the carbonic tree vegetation to limit the absorption of heat and radiation passed into the surrounding. Limiting construction density is also a factor contributing to better regional temperature control. Increasing the use of traditional local material with good thermal performance instead of modern materials such as corrugated irons, concrete, glass. And finally, the drawback of this study is that there is no specific statistic of cooling device like fans used as measurement locations in for survey houses. These measurement areas have absolutely no air conditioner. The author will develop in the following studies. The references used in the research. Thank you for your attention.